This is question number 3 on your asynchronous assignment. So the question states, the magnification of the micrograph is 2000x. What is the maximum diameter of the nucleus in the cell labeled x? So 2000x for the magnification just means that the image is 2000 times bigger than this actual cell would be. That x is not a variable, it just means 2000 times. So we are looking for the maximum diameter of the nucleus. And what that means is we should measure it at its widest point. The relationship is always the same for questions like this. We only have one equation to work with. It is m equals I over a. And we know that that I is the measured size in the image, so measured with a ruler in the image. And we know that A is the actual size. So I for image, A for actual. Okay, what are we given? We're told that the magnification is 2000. 2000x, 2000 times as big. And then it might seem like that's all we have, but because we get I from actually measuring with a ruler, we can take a ruler, and I'm going to try to measure this at its widest point. When you have to make a judgment call, there's always a little bit of allowance in the answer key. So I'm going to call it 2 centimeters. When you're doing this in your assignment, it was just stated that the measured value was 2 centimeters. The reason that I gave that information to you is that I can't ask you to measure it with a ruler because everybody's screen resolution is different, so everybody would get a different answer. But assuming that you take this exam on paper, you may have to use an actual ruler and measure. We'll see what happens. Okay, so with the given 2000x magnification and an image size of 2 centimeters, we can just plug in. So we have a magnification of 2000. We have a measured image size of 2 centimeters. And we are solving for A. So we just need to apply a little algebra, multiply both sides by A, and then we divide both sides by 2000. And we get our answer, the maximum diameter of the nucleus, 2 divided by 2000, is 1/1000th of a centimeter. We would be done, except that we don't have an answer choice that says 1/1000th of a centimeter. Our answer choices are in nanometers or micrometers. So you might have a shortcut, but I'm going to do it kind of the long way in the way that I prefer. We're converting centimeters to micrometers. So there's 100 centimeters in a meter. There's 1,000 nanometers in a meter. I set it up that way so I can cancel my units, get a final unit of micrometers, which is what I want. So 10 to the 6th over 10 to the 2nd by the rules of exponents becomes 10 to the 4th. 6 minus 2 is 4. So we have 0.001 times 10 to the 4th micrometers. So we can move our decimal point. 1, 2, 3, 4. Gives us 10 micrometers. And hopefully you realize that the answer had to be in micrometers because nanometers are too small. Nanometers is a billionth of meter. So micrometers was the unit that we needed to convert to, and now we've done it. Answer choice A is correct.